Myself, JV and Dr. Surendra Kumar Srivastava from the Department of Science under the Faculty of Education and Methodology, Jyoti Vidyapeeth Women's University, Jaipur. Today I will discuss the sequence. A sequence is a function f with domain n and range in the set capital R of real numbers. In symbol form, it can be written as f is such that n tends to capital R. The value of the function f at small n belongs to capital N is denoted by fn. If fn is equal to xn, it is customary to show that to denote the sequence f by the symbol fn or xn, or more in simple form x1, x2, x3 and so on xn. The number x1, x2, x3 and so on xn are called the terms of the sequence. Thus x1 is the first term, x2 is the second term and so on. The nth term xn is called the general term of the sequence xn. For example, sequence 1 by n is the sequence 1, half, 1 by 3 and so on. The sequence n square, it means 1 square, 2 square, 3 square and so on. The sequence k, it means k, k. This sequence is called the constant sequence. Sequence -1 to the power n minus 1 is the sequence 1, -1, 1, -1 and so on. The sequence n upon n plus 1 is written as 1 by 2, 2 by 3, 3 by 4 and so on. And next the sequence is 1 upon root n is the sequence 1, 1 by root 2, 1 by root 3 and so on. And the sequence 1 upon 2 to the power n means thus it can be written as 1 by 2, 1 by 4, 1 by 8 and so on. Now we will understand what is bounded sequence. A sequence xn is said to be bounded above if there exists a real number capital M such that small n belongs to capital M for all xn belongs to capital M. Then capital M is called the upper bound of the sequence. Then capital M is called the upper bound of the sequence. A number which is greater than upper bound is called the upper bound of the sequence an. A sequence xn is said to be bounded below if there exists a real number m such that xn is greater or equal to m for all small n belongs to capital N. In this case, small m is called a lower bound of the sequence xn. Next, every number smaller than a lower bound is also the lower bound of the sequence xn. A sequence xn is said to be bounded if it is bounded below as well as the bounded above. Thus, a sequence xn is bounded if there exists a number m and n such that small m is less or equal to xn is less or equal to capital M for all small n belongs to capital N. Now some remarks. A sequence xn is denoted is bounded if there exists a number capital M is greater or equal to 0 such that mod of xn is less or equal to capital M for all small n belongs to capital N. The sequence 1 by n is equal to 1, 1 by 2, 1 by 3, 1 by 4. Here small m is equal to 0 and capital M is equal to 0, 1. So this can be written as 0 is less than xn is less or equal to 1. Now the sequence n square can be written as 1 square, 2 square and so on. Here small m is equal to 1 and capital M does not exist here. It is bounded below by 1 but not bounded above, so it is an unbounded sequence. Now the next example, sequence of minus n. This can be written as -1, -2, -3 and so on. Here it is bounded above by -1 but not bounded below, so it is an unbounded sequence. Now the next example is sequence of -1 to the power n minus 1. In the expansion form, this sequence can be written as 1, -1, 1, -1 and so on. It is bounded sequence because here capital M is equal to 1 and small m is equal to -1, or mod of xn is less or equal to capital M for all small n belongs to capital N, bounded above by 1 and bounded below by -1. Now the next example, -1 to the power n into n is equal to sequence -1, 2, -3, 4 and so on. Here the value of the upper bound and lower bound does not exist. So the given sequence is neither bounded above nor bounded below. Thus the sequence -1 to the power n into n is unbounded. Now the next example, sequence of sine n pi by 2. This can be written as 1, 0, -1, 0, 1. The given sequence is bounded because it is bounded above by 1 and bounded below by -1 because the range set of the sine function is bounded by 1 and -1. Now the next sequence is 2 to the power n. This can be written as 2, 2 square, 2 cube, 2 to the power 4 and so on. The sequence 2 to the power n is unbounded because it is unbounded below by 2 but not bounded above. Now the last example is 1 upon 2 to the power n. Sequence of 1 upon 2 to the power n. In the expansion form, this sequence can be written as 1 upon 2, 1 upon 2 square, 1 upon 2 cube and so on. The sequence 1 upon 2 to the power n is bounded because it is bounded below by 0 and bounded above by 0.5. Thank you.